Hello and welcome to Server Style Coding. Most Docker tutorials teach you a few commands and then stops, but when it's time to work on real projects, connect multiple containers, persist data, or even deploy your application on a server, that is where everything gets confusing. In this complete Docker tutorial, I'm going to fix that. I'll cover everything you need to go from a Docker beginner to deploying a full stack application on real VPS. We'll cover Docker image, Docker container, volume, networking, Dockerfile, Docker compose, and best practice for building and managing Dockerized application. Then we will put everything together by Dockerizing a real-world application consists of React.js frontend, Node.js backend, Mongo database, and then we deploy it. We will deploy it on a Linux server. Whether you are a front-end developer or back-end developer, or you're just getting started on DevOps, this course will give you the practical skills you need to use in your real projects. So if you want to learn Docker with me step by step with hands-on examples, let's get started. In this section, you're going to learn what is the Docker and why it is so popular. Then we're going to talk about virtual machines and containers. Next, we're going to talk about architecture of Docker. And then we're going to install Docker Desktop. By the end of this section, you will have the clear understanding of what Docker is and how it works. So, what exactly is Docker and why it is so popular? Docker is a software platform, a containerization tool that helps us run our application more easily and much faster on any machine. It is extremely useful during the development, and it is also helpful when deploying or releasing the application. In both cases, it makes our work much simpler. But how does it actually do this? Docker works by packaging the application. That means it takes the application itself along with all its requirements, including softwares, libraries, configurations, and tools, and put them together into a single package. This package is called a container. You can take the container and run it anywhere on any machine that has Docker. So if it works on a development computer, it is guaranteed to work on your test and production or on a server. Now, why is Docker so important? What did we do before Docker and how did Docker make our work faster and easier? Imagine someone joins a team without Docker. They had to spend hours to set up a new machine just to run the application. This process includes installing database, installing softwares, libraries, packages, and all other dependencies. This setup is time-consuming and full of errors because the machine is slightly different. Often things don't work, and the setup has to be repeated from scratch. Now imagine 10 new developers joining the team. The whole process would have to be repeated 10 times. But after Docker came into the picture, everything changed. Now we simply package all dependencies inside the containers in an isolated way. When a new team member joins, they only need to download the container and run simple command, and the entire application with all its dependencies is ready to use. No errors, no repeated setup, and anyone on a team work in a consistent environment from day one. Another common problem happens when multiple applications on the same machine need different software versions. One application might need Node version 16, while another needs Node version 24. Running multiple versions of the same software on one machine can cause conflicts and the application may fail to run properly. Docker solved this problem by isolating everything inside independent containers. Each container is completely separate from the other. That means you can run application that requires different software versions on the same computer without any conflicts. Now let's talk about the deployment. Before Docker, the development team would send the application files, the databases, and the setup instruction to the operation team so they could deploy the application on server. But This process was often difficult. Deployment didn't always work as expected. Sometimes the instructions were unclear or incompleted. Sometimes extra configuration was required. And in many cases, there are version conflicts between softwares. As a result, setting up a server becomes slow, complicated, and full of potential errors. Sometimes there were also communication gaps between deployment and operation teams, which lead to misunderstanding, delay, and repeated work. But today, Docker changed everything. The deployment team built the application as a container and simply deliver the container into the operation teams. As long as Docker is installed on a server, the application runs exactly the same way, with no configurations issues. With Docker, the whole deployment and development workflow become much simpler. We build the container once and we can run it anywhere. It makes server setups much simpler, removes version conflicts, and saves a lot of time. Also, the different applications can run together without breaking each other. At the end, it means faster deployment, smoother development, and more reliable testing. Let's move on to the next topic, comparing virtual machine with Docker. Why Docker is better than virtual machines and how it works? Before diving into the discussion, let's first understand the layer of operating system. This is key to understand the difference between virtual machine and Docker. An operating system has two main layers, kernel and application layer. Kernel layer is at the bottom. This layer talks directly to the hardware and manage system resources. The upper layer is the application layer. This is where programs run. It doesn't talk to the hardware directly. It uses the kernel to access the resources. The difference between virtual machine and Docker lies in layers. Virtual machines have their own kernel, means full operating system, and operating application layer, while Docker only has the application layer and use host computer's kernel. This is why Docker is so much lighter. There is no need to install full operating system. It simply uses the host kernel. Virtual machines, by contrast, are huge, taking up several gigabytes because they include full operating system. Speed is another difference. When starting a virtual machine, you need to wait a minute for operating system to boot completely. Docker doesn't need it because it uses the host kernel, so it starts almost instantly. Resources are another point. With virtual machines, you are limited by computer's hardware, including RAM, CPU, storage, and can only run few virtual machines at the same time. Docker doesn't have this limitation. It shares resources with the host system, so you can run lots of containers at the same time without a problem. Let's talk about operating system and kernel again. As I mentioned before, virtual machines had its own kernel and application layer and doesn't use the host system kernel. That means you can install any operating system on any machine. For example, you can run Linux on Windows or Mac because the virtual machine simulates a full computer. It has his own operating system and kernel. Docker is different. Docker doesn't have its own kernel. It uses the host operating system's kernel. And that means Docker containers doesn't have a separate operating system. On Linux, this is fine. You can run Linux container natively, but on Windows, you can't run Linux container directly because Windows doesn't have a Linux kernel. So what is the solution? The solution is Docker Desktop. Docker Desktop runs a lightweight Linux virtual machine in a background, and Docker run inside it. Your container also run inside the Linux virtual machine. In other words, on Windows or Mac OS, hidden Linux instance starts first, and then your Linux containers run inside it. That is why Docker Desktop lets you run Linux container on Windows. So if your computer is running Windows or Mac, the very first step is to install Docker Desktop. To install Docker, just search for Docker Desktop on Google. The first link here is Docker Desktop official website. Click on Get Started. It will guide you to the download page. Here, download Docker Desktop, choose your right operating system and version. My operating system is Windows, but I recommend you to first read the documentation. So click on Learn how to install Docker. Scroll down to the next step. Here is the Install Docker Desktop. You choose Mac, Windows, or Linux based on your operating system. My operating system is Windows, so I click on Windows. Here explains the installation process in detail, for instance, the system requirements, and also here is the some requirements. For example, you need to make sure WSL is installed and check its version. If it is missing or outdated, install or update it. The guide also gave full instructions for installation. I highly recommend you follow the steps carefully so you can install Docker Desktop without any problems. Here's something important. If you're using Windows or Mac OS, you must install Docker Desktop in order to use Docker. If you're on Linux, you don't actually need Docker Desktop. You just need Docker Engine. However, if you prefer a graphical interface, you can still install Docker Desktop on Linux as well. Now, another key point. On Windows and Mac OS, Docker Desktop must be running in order to use Docker. Otherwise, you won't have access to the Docker engine and won't be able to use Docker. After installing Docker, always verify your installation by running the command docker version. This command checks whether both the Docker client and server are running properly. If you see both client and server information, your Docker environment is ready to use. Now let's take a look at the Docker Desktop interface. As you can see, there is a section called Containers, which shows a list of containers available on your system. There is also another section called Images, which display a list of images available locally. Currently in both sections, and both sections are empty on my system. In this section, we'll move beyond the theory and start working with Docker hands-on. You will learn how to download right image from Docker Hub, create and manage container, expose application ports, inspect logs, access running containers, and understand the complete container life cycle. By the end of this section, you'll be comfortable running and managing Docker container using the most important Docker commands you will use on a daily basis. And now let's go to another very important question, which is what is actually is Docker image and what is the difference between image and the container? Many people misunderstand these two concepts. In this section, we're going to fully understand what is container is and what an image is. As you know, Docker allows you to package your application along with all its dependencies, so you can easily share it or move it into another system. This package includes the application itself, third-party libraries, dependencies, services, application users, files and folders, and environment variables. All of these components are bundled together into a single package. This package is called an image. Now, if it is an image, then what is a container, which we talked about earlier? A container is simply a running instance of an image. In order to use your packaged application, your image, you need to run it. Once you run an image, it became a container. You can run multiple containers simultaneously from a single image. Now that you understand containers are created by running images, the next question is, where do we get these images from? If you want to run a database or a web server or, for instance, MySQL, where do these images come from? Just like GitHub, which is a repository for source control, Docker has its own image repository called Docker Hub. Docker Hub is basically an app store for Docker image. You can search what you need and it is there. For example, Let's say we need MySQL. I search for MySQL and press enter. As you see, there is a multiple results. Some images are created and maintained by official software vendors. Others are maintained by Docker community. As you can see, some images labeled Docker official image, which means they are officially supported and maintained, which is usually our best choice. If you click on one of them, you will be redirected to its page. On the MySQL page, for example, you see different available versions. You can download whichever version you prefer. However, I strongly recommend that you check the tag section. In this section, you will find different version of image. For example, for each tag, you can see the image size and additional details, including how you can pull and use a specific version. You can download an image using the Docker pull command. After typing the Docker pull, you write the image name, then a colon, and after the colon, you specify the tag. The tag indicates which version of image you want and sometimes which operating system it is built for. Based on that, you can choose and install the correct version. If you go back to the overview page, you will also see the tag called latest. This means Docker will download the newest available version. To download the latest version, you can simply write latest instead of specifying a version. But here's my professional advice. Avoid relying on latest. Always specify an exact version because latest can change over the time and that can break your environment. Now let's move on to another image that I want to install on my image, which is Nginx. As you can see, the Nginx image is also created by Docker team. If you open the Nginx page, you can see the latest version, which is 1.29.4. If we go to the tag section, we will see different available versions. The versions differs in size, and depending on the operating system and what additional components are included. I want to install the latest version of Nginx on my system, so I'll use the latest tag and I'll open the PowerShell and type docker pull Nginx latest. If you don't specify a tag, Docker will download the latest tag by default. After pressing enter, as you can see, the image is downloaded. To see the list of the image on your system, you can simply use Docker images command. So I write Docker images and press enter. These commands show all locally stored image. If you have Docker desktop installed, you also can go to the image section here, and as you see in the image section, there is a new image which you downloaded recently. Now, how do we run this image? To run the image and turn it to the container, we use the docker run command. So here I write docker run, and then we type the image name, which is Nginx latest. And if I press enter, the container starts running and showing its logs. If I open a Docker desktop and check the container section, as you see, a new container is here and created from the Nginx latest image. It has a container ID, it has a name, a randomly generated name, and status information. Since it is currently showing logs in a terminal, we cannot use this tab for other commands. So we open a new terminal tab and write docker ps to show the running containers. This command shows the list of running containers. You can see here container ID and also image name, command, creation time, status, and port, and assigned name. There are some details you can see on Docker desktop. If I go back to the first tab and I press Ctrl+C, the container stops. Now if I run Docker ps again, as you see, there is no running container. To see all container, both running and stopped, we use the command Docker PS -A. This shows every container, including the one we just stopped. In Docker desktop, you can see the same information. As you see, here is the container, our container, which is stopped, and you can press the start button to start it again. And you can also run the container in detached mode, meaning they run in a background without showing logs in your terminal. To do this, use Docker run -d, image name, which is nginx, :latest. The -d stands for detached mode, and as you can see, Docker has assigned this container an ID. And if I run Docker PS, the container showing here with the same ID, and if I write the command Docker PS -a, as you see, I have two containers, which one of them is in a detached mode, and the another one is stopped recently, which status is. Here is the key point. Every time you run an image using the Docker run command, Docker creates a new container. So if you don't want to create a new container, what should you do? To restart a container that you previously stopped, you can use Docker start command and specify the stopped container by its ID. Just so copy the ID of a stopped container and here write Docker start and then the ID of the stopped container. And here, if I write Docker PS, as you see, the both container are up and a new container has not been created. As you see, we have two running container, which we run them in detached mode. If you want to stop this container that are started in detached mode, we have two way. First one using the stop button in Docker desktop, and the second way is using the command Docker stop and simply write the ID of the container. And as you see, if I write the Docker PS again, and the container has been stopped. Now let's install a different version of nginx. I want to install version 1.29.3, which is the older version. As you can see, the size of image vary depending on the Linux distribution. I want to install the smaller version, which is Alpine version. So I select the tag, and here in PowerShell, I just simply write Docker pool and then nginx with the colon tag. Since this version is smaller, it will download faster, as you see. If we check with Docker images, we can see two images. One is latest, and the other is the one I just pulled with a specific tag. To run the newly downloaded image, simply write Docker run and then image name with tag, which is nginx :1.29.3. Note about the Docker run command. If you run Docker run command without pulling the image first, Docker will automatically check the system. If the image is not found locally, it will pull it from the Docker hub. So even if without running Docker pull, Docker run will still download the image if needed. I forgot to run it in a detached mode, so I stop it with Ctrl+C and run it again using the detached mode with -d after run. Now, if I run again Docker PS, as you can see, now we have two running container, two running nginx container with a different version, nginx latest and nginx version 1.29, two version on the same machine at the same time. This is the power of Docker. But there is a very important note here about the ports. As you see, both containers trying to use port 80, which is the default port for nginx. This can cause a conflict. Docker provides a simple solution for this. You can map each container to different host port. A container is like a virtual machine, as you know. It has its own port, operating system, and services. The host system communicates with the container through the mapped port. You can change the mapped port, for example, assign port 8080 for the first container and, for example, 8081 for the other container. Let's do it together. So first, I stop both container using Docker stop and the ID of the container. After stopping both containers, I'm going to create a new container and assign its host port. This allows you to run multiple containers simultaneously without port conflicts. To assign a ports to container, use the -p option of the Docker run command. So I write Docker run -d for detached mode and then -p for assigning the ports. For example, I want my host machine's port 8080 to map to the port 80 of the container. So I write 8080:80. And then we have to write the image name, which is Nginx latest. After running the container, if we check Docker PS again, you'll see the containers is now accessible on port 8080 on my local machine. I can test it easily by opening a browser, and here I check, I write localhost port 8080. As you see, Nginx responds perfectly. For the another port, I can do the same, run it in detached mode with -d and then -p for assigning the port. I want to assign port 8081 to port 80 of the container, and I write the image name, which is Nginx :1.29. As you see, the port 8081 of the host is not available, so I use another port 8082, and as you see, the port is available. And now if I go back to the browser and I check for localhost port 8082, as you see, the another version of the Nginx is available in this port. So we have two Nginx with different version available on my system. Let's move on to another very important tip. Stopping and starting containers using their IDs can be cumbersome. Instead, you can assign a custom name to each container when creating them simply by --name option. So you can easily create and run the container with, for example, I write Docker run -d for detached mode and -p for assigning the port. This time I want to assign 8083 to port 80 of container. And I want to assign a name with --name option, and this option allow you to specify a specific name, custom name for the container. I want to call it Nginx-old, and then we have to write the image name, which is Nginx :1.29. And now if I write Docker PS again, as you see, we have three containers. The third one, which I create lately, is named Nginx-old. You can use this name for stopping and starting the container. For example, I can stop it easily with Docker stop and then Nginx-old name, the custom name which I created for the container, and I can simply again start the container with this simple custom name. As you see, most of the time we run containers in detached mode. Although most containers are run in detached mode, logs are not available. But sometimes we need to inspect containers log. There is a solution for that. There is a command docker logs which show the logs of the container. But first, let's try the --help to see the options this command provides us. First option is -f, which allow us to follow logs in real time. The second option is -n or --tail. We can specify the number to show the from the the end of the logs. And the last one is -t or --timestamp, which shows the timestamp of logs. Let's try all of them, but first of all, let's simply try the Docker log and then specify the container's name. We can specify a container by its name or ID. This time I want to write the name of the container, so I write nginx-old. As you see, the logs are displaying, and it's not real time, so let's try the real time logs. I write Docker logs and then -f. As you see, it prints logs. It keeps showing new logs in real time continuously linked to the container until I press Ctrl+C. You can also use -t to see the timestamp of logs. You can, as you see, the timestamp of logs are shown in the logs. You can also use -n and specify the number you want to see from the last logs of the container. I write 5. As you see, there is 5 last logs. You can use -n with -t to see the timestamp of logs. So far, we've create container, user docker run command and execute images. But there's another useful command, which is docker exec or docker execute. This allows you to run additional commands inside running containers. For example, let's write docker exec, and I want to write it in interactive mode, so I write -it. And now you can specify the ID or name of the container. I write the nginx-old. And now I want to see the bash or shell of the container. So I write /bin and bash. Note that this container is running on Alpine Linux, so it doesn't have bash. So we can use a shell. So I write /bin/sh, and when I press enter, as you see, I'm in a shell. I can easily write Linux commands. For instance, I want to write ls to see the list of the files inside the container, and or I can write the pwd command to show me the current working directory, or I can write any other command like anv to see the display the environment variables. To exit the shell, I can easily write the exit and press enter. And our final topic is about removing containers and images. You might have many containers and images on your system and you want to clean them up. In Docker Desktop, you can simply select any container or any image from the list and just press the delete button to delete it. Or you can select all and press the delete button in above and remove them all. But on a server or systems without a graphical interface, you manage everything with commands. We won't always have access to Docker Desktop, especially on Linux server without a graphical interface. So we need to manage everything with a command line. To remove container, you can simply use the rm command, which is shortened for remove. So I write docker rm, and then you can specify the ID or name of the container. For example, I want to remove the container named nginx-old. As you see, I'll get an error because the container is still running. So first I have to stop it. Two options I have. First, I should stop first and remove it, or I can remove it with -f command. -f means force, and you can remove running container with -f. Now if I check with Docker PS, as you see, nginx-old is gone. To remove images, we can simply use docker rmi command and then specifying the image name. But there is a very important point here. You cannot remove an image if a container is still using it. First, make sure no active container are associated with that image. So I write there is an container who using this image. So I write docker rm and then -f to remove this container. and then I can write, I can delete the image with docker rmi command and then specifying the name of the image. But I get another error here, because if other containers exist that use this image, even if they stopped, you need to force remove with -f. So I write docker rmi -f to remove these containers, and this command first untag and then delete the image. You learn how to remove container and image with rm and rmi command, but instead of removing container or image one by one, you can use prune to clean up everything inactive. Let's first check the containers with docker ps-all. As you see here, there are tons of containers which status are exited. We can simply prune or delete all these containers with a docker container prune command. If I type yes and confirm deleting them, all of them will be deleted with a single command. Similarly for image, docker image prune, this command delete all unused image after confirmation. In my case, the only image still in use is Nginx latest, which is still in use, so the docker prune won't delete that. In this part, we're going to use Docker in real development scenario. Our goal is to work with MongoDB database and perform a simple read and write operation. But instead of installing Mongo directly on our computer, we will use its image to run it inside the container. To make things easier, we also set up a graphical interface using the Mongo Express container, so we can access our database and interact with our database visually. Next, we will create a Docker network to allow our containers to communicate with each other. By placing both containers inside the same network, they will be able to connect using their container names. Also, we have a simple application consists of React.js frontend and Node.js backend. This application will handle creating, deleting, and displaying user by communicating with our MongoDB container. We're going to make it together step by step, but in this section, we're going to do manual using the Docker commands. In the next part, we will automate the whole process with Docker Compose. Let's start by pulling the image we need from Docker Hub. Now, we go to the Docker Hub and search for Mongo. As you see, there is an official image for Mongo. And when you go to the page, you can see how to download it with Docker pull command. And if you want a specific tag, you can search for it. But for now, I just want to download the latest version. So I write Docker pull Mongo. After pulling the Mongo, it's time for Mongo Express. So in a Docker Hub, I search for Mongo Express, and as you see, it has a Docker official image for Mongo Express. In its page, you can see how to download it, how to pull the Mongo Express, but this time I'm not using the specific tag. I want to download the latest version, but it's better to choose a specific tag for your need. And now let's move on to PowerShell again. And here, let's type docker pull mongo-express. After pulling the image, it's better to make sure everything is installed successfully by running the command docker image. As you see, the Mongo Express and Mongo installed and pulled successfully. Now we can create containers from these images. However, our goal is to have a MongoDB and Mongo Express communicate with each other. To make that happen, we need to put both containers inside the same isolated Docker network. This way, instead of connecting using IP address and ports, they can simply use container names to talk to each other. So, before creating the container, we'll first create a dedicated network for them. But before that, let's take a look at the existing network on our computer. So run docker network ls. These commands list all the Docker networks currently available on our computer. There's a 3 default network created by Docker itself. So I write the command docker network create, and then I choose the network name. For example, I write Mongo network, Mongo-network. And as you see, the network is created. If we run the ls command again, docker network ls, you'll see our new network is added to the list. Now it is time to create the Mongo container. But before we do that, let's quickly go back to Docker Hub and review the official documentation for Mongo image. On the Mongo image page, if you scroll down, you'll find an instruction on how to run the container properly. As you can see, we need to define a couple of important environment variables when creating a Mongo container. In Docker, the environment variable are passed using the -e flag. After each -e, we need to specify a variable name, and then we have to assign a value for it. For Mongo database, for Mongo container, we need to essential environment variable, Mongo initdb root username and Mongo initdb root password. These define the username and password that we will need to connect our Mongo database. We also need to specify the network. By specifying that, containers running inside the same network can communicate with each other using their container names instead of IP address and ports. For the network, we use the -e network flag, and then we provide the network name which we created earlier. Now let's go ahead and create Mongo container. As usual, we use the docker run command to run the container in background. We add -d for detached mode. Next, we use -p flag to map ports. In this case, I map port 27017 on my local machine to port 27017 inside the container. If you are not changing the default ports, you can skip port mapping. Now let's move on to the environment variables. As I mentioned earlier, we use the -e flag to define environment variables in Docker. The first variable is Mongo init, Mongo underline init db underline root underline username, and then equal, and I'll use admin as the value. Then we define the second environment variable with another -e. This one is Mongo underline init db underline root underline password, and I'll set it to something like pass1 2 3, and these credentials will be used later to connect our Mongo database. Now we need to specify the isolated Docker network for this container. Earlier we created a network called Mongo-network, so we can use the -net or -network flag and pass that name, which is Mongo-network. Next, we assign the name for the container using the --name. I'll call it a MongoDB. Finally, we should specify the image name, which is Mongo. Since I pulled the latest version, I don't need to include the tag, but if you pull the specific version, make sure that include tag as well. Once we run the command and press enter, the container is created. To be sure everything is running correctly, it is a good idea to check logs. So I write docker logs, and then you should specify the container name. It is MongoDB. As you see, if I look at the logs, you can see there is no error, which means container is up and running. Now it is time to create our second container, which is Mongo Express. As usual, let's first take a look at the documentation on Docker Hub. Here you can see the list of the environment variable for configuring Mongo Express. We don't need all of these variables, but some of them are important and we have to set them. For example, meconfig basic OS username and password. These are used to set the username and password for accessing Mongo Express UI. By default, they're empty, so it's better to set them when creating a container because without setting them, the access will not be possible. There are other key environment variable, meconfig, MongoDB admin username and password. These should match the username and password we used and we defined when creating Mongo container. There are other important environment variable, meconfig MongoDB server. Here we specify the name of the Mongo container, which in our case is MongoDB. Here is another environment variable, meconfig MongoDB port. If you have changed the default MongoDB port, which is not very common, you can also set this variable. A little bit at the bottom here, you can find an example command. And as you see here, the network is specified. Now that you understand the required configuration, let's go ahead and create the Mongo Express container. To create this container, we use the docker run command again. As before, we add -d to run it in detached mode. We can also use -p for port mapping. By default, Mongo Express runs on port 8081. I'll keep it as it is. But if you are not changing the default port, you don't necessarily need to specify it. Let's move on to the environment variable. The first environment variable is UI username. I choose Sarvin, another -e for the UI password, which is basic OS password. I choose Sarvin pass. Another environment variable with another -e is username and password of the database. The first one is admin username. As you remember, the admin username was admin, and another environment variable is admin password. And as you remember, the admin password was pass 1, 2, 3. The last environment variable is the server name or container's name. So I copy the last environment variable and I set the MongoDB for server name, which is the container name. Now we have to specify the network by --net or by --network. The network name was Mongo-network. The next step is to assign a name for container with --name. I call it Mongo Express without dash. Finally, we have to provide the image name. Mine is Mongo-Express without tag because I use the latest tag. If you choose another tag, you have to specify the tag. As you see, the container is created. So let's check it by Docker logs and container name Mongo Express. As you see, it's not ready. So I write docker logs with -f. And after a couple of the seconds, as you see here, the container is ready and listening at port 8081. Now to test everything, let's open the browser. In the address bar, go to localhost 8081. Once the page loaded, you'll be prompted to enter username and password. In my case, I'll use Sarvin as username and Sarvin Pass as the password. And as you can see, Mongo Express loads successfully and it's connected to MongoDB database without any issues. Now I want to create a new database here using Mongo Express. I call it user_db. When we click on the database name, we redirect it to database page. Here I create a new collection called user. The collection is something like tables. As you see, table is created. Now let's using containers in development process. I have a simple application with a Node.js backend and React.js frontend. I want to connect the Mongo database through the backend and perform a read and write operation. Here in Node.js, index.js file, we define the connection to MongoDB. As you see here, we have this connection. This is the protocol, and this is the address and port number. This is admin user and password. As you remember, we define admin for username and pass 123 for Mongo container pass, and this is the database name which we created earlier. As you see, here is the get and the command for creating users, and this is the command for deleting a user. Now let's go back again to React app to check whether our changes are correctly applied to the database or not. I'll create a new user named Sarvin. As you can see, Sarvin has been added here. Let's add another user. Let's check it in a Mongo database. When I refresh the page, as you see here, the user Sarvin is created. Now let's add another user. So I go back to the application and I add Sam here. As you see, Sam is created. Let's check it again. As you see, the Sam is created and it is here. Now let's delete the user. And after refreshing again the database page, as you see, Sam is removed. In this way, we were able to set up a Mongo database using containers and perform read-write operation on it. We also created a Mongo Express container, and by setting up an isolated Docker network, we connect both containers so we could have UI for easier access to Mongo database. In this lesson, we're going to learn one of the most important tools in Docker, which is Docker Compose. With Docker Compose, we can define and run multiple containers using just one simple file and a single command to make our workflow cleaner, faster, and much easier to manage. In a previous section, as you see, we created Mongo database and Mongo Express containers manually by running multiple Docker commands in a terminal. We also create a Docker network and connect both containers together so they could communicate with each other. But honestly, running services in this way can become difficult very quickly. We need to write many commands in a terminal and repeat the same steps again and again, and sometimes even a small mistake can cause problems. This is exactly where Docker Compose becomes very useful. With Docker Compose, instead of writing many commands manually, we put everything inside a single file. Then, with just one command, Docker can automatically run and create containers. So in this lesson, we're going to take all these commands and convert them into a Docker Compose file step by step. Before we start using Docker Compose, we need to make sure that it is installed on our system. If you are already installed Docker Desktop, you do not need to install Docker Compose separately because Docker Compose is included with Docker Desktop. However, if you are using Linux without Docker Desktop, you may need to install Docker Compose manually. For Ubuntu and Debian, sudo apt-get update and sudo apt-get install docker-compose-plugin. And for RPM-based distribution, sudo yam install docker-compose-plugin. After installing the Docker Compose, you can verify it by running this command, docker compose version. And as you see, my Docker version is 5.1.3. Now it's time to create our Docker Compose file. Docker Compose files use YAML. So before creating our Docker Compose file, let's first understand the basics of YAML. Let's compare it with a simple JSON file. Here we have a basic JSON example with a list and also an object called author. Now let's convert it into a YAML step by step. So I copy all the items and paste it here in the sample.yaml file. First, we remove the curly braces because YAML does not use them. So I remove them, and also in most cases we do not need double or single quotation marks, so we can remove those two. And unlike JSON file, we also do not need comma at the end of each item, so I remove all. Very important thing is YAML is indentation. Spacing really matters in YAML files, so we must always keep the correct indentation. So I remove the spaces in beginning of the items. And now let's see how list works in YAML. We do not need to use square brackets anymore. Instead, each item goes on a separate line. And before every item, we must add a hyphen followed by a space. And also we do not need a comma. So each item in a separate line and a dash or hyphen at the beginning of each item create a list in YAML files, as you see. For objects, we also remove the curly braces. Again, no comma are needed. And also we simply write each property on its own line while keeping the correct indentation. So as you see, I remove the curly bracket and the spaces at the beginning and adding a tab at each item, removing the comma. And just like before, quotation marks are usually not necessary and can also be removed. Once you understand these basic YAML rules, reading and writing Docker Compose files become much easier. Now that you're familiar with the basics of YAML, let's start creating our Docker Compose file step by step. The file extension must be .yaml. There is also common naming convention for Docker Compose file, and usually they are named docker-compose.yaml. As you can see, when I use Docker, the naming convention docker-compose.yaml, the file icon even changed to the Docker icon in the same editor. But this time I want to use different names, so I call this file mongo.yaml. Then I open this file to write the codes, but next to this file, I wanted to open the Docker commands that we used in the previous lesson to create MongoDB and Mongo Express containers. As you see, I opened both of them side by side. In this way, it will be easier to compare Docker commands with Docker Compose configuration. The first thing we need to write is services. In the next line, we should specify the containers or services name. As you can see here, we have two containers, MongoDB container and Mongo Express container. We name this container, you choose a name for this container. The first one was MongoDB. and the second one was Mongo Express without a dash. So I should specify the name for the containers here also. So I write Mongo DB 1 for the first service container and colon. Then for the second container, Mongo Express 1 and colon. Remember, you have to space at the front of each line. The indentation is very important. And the second thing we have to do is specifying the image name. For the first container, the image name was Mongo. And so I write image and colon. And here I specify the image name, and mine was Mongo. I use the latest tag, so there's no need to write the latest, but if you use another tag, you have to write it here. In the next line, we have to specify another important thing, which is ports. And as you can guess, you should write like a list, so with a tab and a dash. We specify the port numbers, which is 27017 for both container and host port. After the ports, there is another important thing we have to specify, and it is environment variable. So I write environment here with colon, and in the next line, the environment is a list. So in a next line with dash, I write the environment variable with value separated by equal sign. And we have two environment variable. And as you see here, the MongoDB configuration is done, and it is time for the other container, which is Mongo Express. The first line is belong to image, so image colon, and the image name is Mongo Express. I use the latest tag, no need to write it. The second line is the port number, so I write ports. In the next line, with a tab at the front and a dash, I add the port number, which is 8081. The last variable here is environment variable, and I specify file variable. So I add the dash, and I copy all the environment variable here with the value. As you see, the Mongo Express container is done. So my YAML file is ready, and as you see, there I don't specify the network for my services because Docker Compose file automatically create and specify Docker isolated network for the containers, so there's no need to create and add network to each container. Now that our Docker Compose file is ready, let's run it. To do that, we first need to open the terminal and navigate to the folder that the Docker Compose file is located. Here we write Docker Compose. If the file name and docker-compose.yaml, there is no need to specify the file name because the Docker Compose will detect it automatically. But since I use different name, I need to provide the file name with -f. Using -f, then the file name, which was mongo.yaml, and then we write up to run the Docker Compose file. After we press the enter, as you see, and it runs and the container start running. But in the top, you see the network is the first thing created. As I told you before, the network automatically create, and there is two other container, the MongoDB one and Mongo Express one also is created. In the logs, you can see the Mongo Express is created faster, but MongoDB is still starting up. So the first connection here failed, and as you see, waiting for Mongo at port 27017. But after a few seconds, once the MongoDB container is fully ready, Mongo Express successfully can connect to it. And as you see here, the terminal shows that Mongo Express is available at the port 8081. Now let's open the browser. I'll go to localhost 8081. I'll enter the username and password. The username was Sarvin, and the password was Sarvin Pass. And now we are inside the Mongo Express. And next, I'll create a new database called user_db. So I press the database box here and the UserDB and creating the database. As you see, the database is created. Now let's stop the containers. One way is to simply press Ctrl+C here in the window we are showing the logs, or you can open another terminal and go to the folder where Docker Compose file is located. And here run Docker Compose, and with -F you can enter the file name. But if your file name, Docker Compose file name, is docker-compose.yaml, you don't need to specify the file name, and then you write it down, and this will stop all the containers and remove them. So I write it down here. And after I press the enter, as you can see here, the containers start to stopping. The first container Mongo Express stopped and removed, and then the MongoDB, and then the network also is removed. So when I write here Docker network ls, as you see, there is no network name, Docker test app underline default. Now let's start everything again. I'll run Docker Compose again, Docker Compose Mongo YAML up. And as you see in the next window, when I write Docker network ls, you can see that network has been created again automatically. And if we open the Docker desktop, you can see a group container here. When I click the arrow here, you notice the database MongoDB and Mongo Express containers are here. Let's go back to the browser, and here as you see, the Mongo Express is ready, but there is no database name user_db. Reason is that when the container are removed, the data inside them is also removed. That means all the database changes we created are lost when the container are deleted. But Docker has a solution for this problem too, and this is called Docker volumes. In future lessons, you will learn Docker volumes completely, so your data can survive even after stopping containers or running Docker Compose done. There is still one important thing to know about Docker Compose. Docker Compose is built on the top of the Docker engine. That means almost everything you can do with Docker can also be done with Docker Compose. So right here, Docker -compose, and without any option, press enter. Here you can see all the commands and provided by Docker Compose, included build, rm for removing the stop service, push, pull, and but the important difference is Docker Compose work at the application level. So instead of working with a single container, these commands usually apply to all service defined inside the Docker Compose file. Now let's look at another example, Docker -compose and build. Compose build. And with that dash help, you can see the options it's provided here. You can see the build command, build or rebuild the services, so you can use it instead of Docker Compose up. And as you see here, there is no cache. When you can use it when you want to do not use the cache while building an application. We also have push and also have pull that attempt to pull a newer version of the image. So this is very useful, and you can use this command instead of Docker Compose. So you are familiar with Docker Compose and how it works. From now, instead of writing a long Docker commands manually, you can manage your entire application with much cleaner and more organized approach using Docker Compose. In this part, we're going to Dockerize our application. Dockerizing is the process of packaging our entire application, including source code, dependencies, libraries, and configuration files into a single Docker image. The main advantage of this approach is probability. Once the image is built, we can run the application on almost any computer without worrying about the environment differences or missing dependencies. When we run the Docker image, Docker automatically create a container, start application, and make it accessible. To build this image, we need to create a file called a Dockerfile. A Dockerfile contains all instructions required to build and run the application, such as installing dependencies, copying project files, configuring environment variable, defining port, and defining the startup commands. Docker provides several important instructions for writing Docker files, including from, workdir, copy and add, user, cmd, and entry point. In this video, I will explain each of these instructions step by step by real examples. Along with Docker commands, we will also use some Linux commands. So if you are not familiar with Linux, I highly recommend learning the basics. But if you don't have time to learn the Linux basics, don't worry. Throughout this tutorial, I will explain every Linux command I use so you can understand exactly what is happening in each step. Now, let's begin by creating our Docker file and adding into the project. Our project is very simple. It has a Node.js backend and React.js frontend. Once we're going to Dockerize frontend, so inside the frontend folder, we create a file named Dockerfile with capital D, and as you see, the icon changed to Docker image. Now it's time to start writing our Docker instruction inside the file. The first instruction is from. From instruction is used to choose the base image for our application. In simple words, it defines the environment our application will run on. The base image can be a simple operating system image, but in most real projects, the better approach is to use image of technology your application is built with. The reason is Docker images are built in layers, and most images already have their own base image underneath. So the Node image already includes operating system and everything required to run Node.js application. If you are not sure which image you should use for your project, you can check the Docker docs. Docker provides complete example for many different technologies and framework along with their Dockerfile. For example, by looking at this example, you can easily understand Dockerfile are structured and which image is recommended for your project. For example, Python project usually use Python-based image, JavaScript project and Node.js project typically use Node.js based image, and for .NET application, Docker also provides official sample project and Dockerfile. For example, here in a app folder and inside the ASP.NET app, you can see the Dockerfile. In Dockerfile, you can see the base images ASP.NET, and as you see here, sometime an image includes a full registry pass before image name. That usually means the image is hosted outside of the Docker Hub. In that case, beside the image name and tag, you also need to specify the registry address and where the image is stored. Now let's go to JavaScript section. For example, here we have a sample project that uses React Express and MySQL. If we open the frontend and a Docker file here, as you can see, it uses the base node base image node LTS. By exploring the rest of the Docker file, you can get a good understanding of how Docker images are built and how you can write the Docker file for your own project. Now let's come back to our project. Since our frontend is built with React.js, we should use node image as our base image. But there is one very important thing you should avoid doing. Never use a base image without tag, for example, or using latest tag, because if you do so, Docker will automatically pull the newest available version from Docker Hub, and that version may not be compatible with your project, and your project might not work correctly. There is why always a good idea to check Docker Hub for choosing an image tag. Here on a node page, you can see images with different sizes, around 400 to 300, and others might be smaller. The reason is that the images are built in different Linux distribution, and the Alpine distribution is much smaller. So if I search for Alpine here, you can see the image size is only around 40 to 60 megabyte. Here I'm looking for Node.js version 24, and I choose the first one, the version Alpine 24. And now, before we add the Docker file, there is one more thing you should know. If you look carefully at each image, exactly provides a multiple compressed file with different sizes. Docker automatically select the correct version based on your operating system and CPU architecture. Then it download and install the version that matches your computer. Let's paste the tag here after the colon. And before writing the rest of the instruction, I want to build this image because you can clearly see what each instruction does and how it affects the final image. Now, let's build the image. Open PowerShell or terminal, then navigate to the directory where Dockerfile is located. And here you should write docker build -t. -t option allows you to define the name and tag for the image. I choose a custom name, React test app, and after the colon, I specify the tag v1. If you don't specify tag, Docker automatically assign the latest tag by default now, and a dot for specifying the Docker file location. And if you press enter, the Docker file is created and the image node is downloaded. Here, if you write the command docker image, as you can see here, my image is created and the version is v1. Now that our image has been created successfully, let's run it and create a container from it. To do that, I run docker run -it and I paste the container image name, which is React Test App v1. And when I press enter, the container created, and we are in a node environment, as you can see, and can write the JavaScript command like console.log servin. And when I press enter, as you see, the servin, it prints servin in a console. And now I press .exit to exit the container, and let's see what file and folder exit inside the container. To do that, we need to open a Linux shell or bash environment inside the container. So I run the image again, but this time at the end of the command, I specify the shell or bash. Normally, many Linux distributions use bash. However, since this Node.js image is based on Alpine Linux, bash is not installed by default. So if I try to run bash here, I got error, as you see. Instead, I use sh for shell, which opens the default shell environment inside the container. And now we are inside the Linux shell and we can run Linux commands here. For example, I run ls, which is used to list files and directories. And as you can see, after I press the enter, it displays all the files and folders inside the container. And right now our application files are still not inside the container. So let's go back to Dockerfile and copy our project file into the image. In Docker, we have two instructions for copying files and folders, which is copy and add. These two instructions are very similar. However, the add instruction provides some additional features that I'll explain later in this tutorial. For now, let's start with copy. The syntax is very simple. First, we specify the file or folder name. Then we define the destination path. So I want to copy package.json file inside the folder named app. So I add /app. But if you want to add multiple files, we can simply add file names separated by spaces. For example, I can also copy the readme file, readme.md file here. One important thing to remember is that our image is running on Linux, and Linux is case sensitive, so you need to be careful about the lowercase and uppercase letters when writing a file or folder names. Now, as you can see, Docker returns an error for app. That's because when you copy multiple files, Docker expects the destination to be a directory, so we need to add a slash on the end of the destination path to indicate the folder. We can also use pattern for selecting files. For example, I want Docker to copy every file started with package and ended with JSON. So I use star, which is the wildcard. I add the star after the package, and it's copy package and package lock.json. Now, for copying everything from the directory, including all files and folders, I can simply use dot, which represent the current directory. There is another useful instruction, which is workdir. The workdir instruction defines the default working directory inside the container and tells Docker all commands should run inside that directory. So I write workdir and choose the app directory as a work directory. In simple words, it defines the location where the next Docker instruction will run. So after writing the work directory, I can simply add dot because the current directory is now /app. Now let's talk about file names that contain spaces. For example, let's change readme file to readme with space between read and me. If we write it normally, Docker will return an error because it treats space as a separator between arguments. For a situation like this, we should use array syntax. It means we place the files inside the square brackets and here. And then wrap each file names with a single quote or double quote and separate them with commas. Another important thing you should remember is that when copying multiple files, for example, when I add the file mongo.yaml here, the destination path should end with /. In this way, we tell Docker that the destination is it not file, is a directory. Now let's move on to, let's remove all of these and use dot to copy all files to the app folder. And now let's move on to the add instructions. We talked about earlier, we said that add is very similar to copy, but it provides a few additional features. One of these features is downloading files directly from URL. For example, if you have a file hosted online and you want to include it in your image, you can write the address by HTTP, like HTTP / and the path, and writing the file name, for example, test.json and dot for destination. Docker will automatically download and copy the file into the app folder. Another useful feature is automatic extraction of compressed file. For example, if I write Docker and for example, I write a file, zip file like a.zip here and dot for the destination, Docker automatically extract the content of a.zip and copy all the extracted files into the app directory. Now let's remove the add instructions, because while you don't need one of these features, try to use copy instead of add. Now let's build our image again from scratch. So I came back to the PowerShell and I moved to the directory with my Docker file is located, and here let's write Docker and build-t and react-test app v1 and dot. This time the build process take a bit longer because Docker is copying all the project files into the image. Now, as you can see here, the transferred content is around 300 megabyte. And now let's run the container. I use the command docker run -it react test app v1, and I want to run a shell, so I add the sh at the end of the command, and you will see that we are inside the app directory. This is because the workjar instruction we defined earlier. So I use the ls. This command shows all files and folders inside the app folder. So you can see that the project files are now inside the container, and our application code is fully copied into the Docker image and is accessible. There is one very important thing we need to talk about here. If we go back to Docker desktop and check the React test app image, you can see that the size is around 473 megabyte, which is quite large since Docker images are usually transferred over network. Larger image takes more time to upload, download. They also increase the image build time. So the question is, how can we reduce the image size? If we go back to the project, remember that we earlier copied everything using copy dot command. The problem is there is also copied node module folder, which is very large, but we actually do not need to copy this folder because as long as we have package.json log, we can easily recreate it inside the container simply by running the npm install command. How can we exclude the node module folder when using copy dot? This is exactly where Docker ignore files become useful, which is Docker ignore works similarly to git ignore. Let's create this file. It starts with dot, and we write all the letters Docker ignore with lowercase, and as you see the icon changed to Docker icon, and here we write the files and folder names which is we want to be excluded. I add slash for node module at the end of the node module to indicate it is a folder, not a file, and as well as we add the node module here. When we rebuild the project, this will be excluded. So let's exit here and let's run the build the image again. As you see here, the transferring content and it become very low, around 5.20 kilobyte. And let's clear here and go back to the running the image inside the shell, and let's run the command ls to see the files and folder. Here, as you can see, that node module folder is no longer inside the container, and that means our Docker ignore file worked correctly. Now we need to recreate the node module folder inside the container by running the npm install command. So let's go back to Dockerfile. If we want to execute Linux or Windows command inside the Dockerfile, we use the run instructions. So here I write run and the command, which is npm install. This means that during the image build process, Docker will execute the npm install command inside the container, and the node module will be created. We can also run other operating system commands the same way. For example, we can write run apt install Python. But if we try this command here, it will fail because our images are based on Alpine Linux, and Alpine does not use apt as its package manager. Instead, Alpine use APK. So we have to use APK for our image. For now, I removed this example and I try to build the image again. So let's move back to the here, and let's exit the shell, and here I build the image again. Now if you watch the build process carefully, you notice that Docker completes the previous step very quickly, but npm install step keep longer because this stage is where Docker downloads and install the project dependencies on it. And now let's run the image in shell mode, and let's run the ls command, and as you see here, our node module is created. Besides the run instructions, Docker also provides two other instructions for executing commands inside container: CMD and entry point. The syntax of CMD is different from run. Instead of writing commands normally, we usually write them in array format using square brackets and quotation marks, and we write the commands separated with comma. For example, I write npm comma start or install. But the real difference between run and CMD, it is not a syntax, it is execution time. A run is a build time instruction executed during the image build process, but CMD works differently. It runs when container starts, so it is a runtime instructions, and that is why the CMD command should be written at the end of the Dockerfile. And another important thing to remember is that we should only use one CMD instruction inside the Dockerfile. If we use multiple instructions and the Docker execute only the last one. Docker also provides other instruction called entry point. The syntax is very similar to CMD. It is also usually written in array format. However, there is an important difference between them. The CMD instruction can easily be written when starting a container. For example, if our Dockerfile contains npm install, you can replace it at runtime with another command like sh shell or with echo hello when running the container. So when you run the container, the npm install is not executed and echo hello will execute it. But entry point behaves differently. It is not easily written. If you want to replace entry point command, you usually need to explicitly use the -- entry point option when running the container. So if you want to replace the echo hello, you have to use -- entry point to replace it with npm install. So the entry point is more reliable instructions and help us to prevent main container command from being accidentally replaced by other command when a container starts. Now let's talk about environment variables. In our test project, we already using a environment variable. As you can see in API.js, we used React apt API URL. As you can see, this variable stores the API URL used by our application. So we need to define this variable in our Dockerfile to work properly. So for defining the environment variables, we should use the env instructions. And as you see, we should specify the key and value. Our key is React app API URL, and for the value, we usually don't need quotation marks around the value. If you want to define more environment variable, we simply write additional env instructions in separate line and provide their names and values. Now that we know how to define the environment variable, let's build the image again. As you can see, the image is built, but this time You notice that the npm install step again took a long time, and Docker didn't use that cache for that layer. Later in this video, I'll explain why it happens and how we can optimize it. Now let's run the image again and enter in shell environment. I want to check whether our environment variable was created correctly or not. For that, I use print_env command, which shows all environment variable in the container. As you can see, our environment variable is here and created successfully. Now let's talk about users. By default, Docker run application using the root user, which has the highest level of permission inside the container. However, in most cases, it is considered better practice to create and use user with more limited permissions. Otherwise, running everything as root can potentially create security risk. Now, for a simple project like this React.js application, creating a custom user is not really necessary. But creating custom user is an important Docker concept, so let's create a new user together and learn how it works. In Linux, we create users by running the add user command, and because it is a Linux command, we execute it using the run instructions. In Linux, users are usually associated with group as well, so first let's create a group using add group command. I write add group and I use -s option to create system group, and then give a group a name like app. And now I want to create a user itself. To write multiple commands inside a single run instruction, we can connect them using add sign. And then we use the second command, which is add user. After that, I use -s option to create a system user. And then I provide the username, which is app. After that, I use a -g option to specify group name, which is app. Usually, it's common practice to keep username and group name the same for simplicity. And finally, the user instructions. I specify that this point forward, the container should run using app user instead of the root user. Now let's move back to PowerShell and build our image again. Now let's run the container again, and this time I want to check which user is currently active inside the container. So I use the whoami command, and as you can see, the current user is app. But before we move on, let's run another command, which is ls-l. The L command shows the owner of files and folders. So let's look carefully. As you can see here, all files and folders owner is root. And it means that our app user only has limited access to this file. As you can see, it has the read only access. So we need to make change inside the Dockerfile to fix this properly. So let's move back to our Dockerfile, and here we need to, the first important thing is that user creation should happen earlier in Dockerfile layers. So I moved the adding the user and group after the node import, and also add user after the work jar. But if we try to build the image again, Docker return an error saying that app user does not have permission to perform the copy operation. The reason is that instructions like workdir and copy are executed as root by default. And since we switch the container to use app user, permission problem starts to appear. So before using the app user, we need to assign ownership of the app directory. correctly. To do that, we can use a Linux command, which is name is chan. For the running the Linux commands, we need to use run instructions. So I write here run, and for the command I write chan -r and app for user and another app for the group, and /app for the folder. This command changes the ownership of app directory and assign it to app user and group. Now there is one more important thing we should improve: the copy command. We want copy instruction done by app user instead of root user, so we should add the chan option here, and as you see, we should specify user and group. I write app for user and also app for group. So in this way, all project files and folders are copied with app user ownership instead of root. Now let's rebuild the image and test everything again. So I move back to PowerShell and rebuild the image. As you see, the image is built successfully. Now let's run it and run the command who am I. As you can see, the who am I, and as you can see, the current user is app. Now let's check the file permission again with ls-l, and this time, as you can see, all project files and folder are owned by app user. So now the app user has the current permission to access and work with the project file inside the container. It's time for the final topic, optimizing our Dockerfile. So far everything works correctly, but you may have noticed something important. Every time we build the Docker image, the npm install takes a long time to run again. To understand why this happens, first we need to understand how Docker builds images. Docker process a Dockerfile layer by layer. Each instructions creates a new layer, and if a layer has not changed, Docker simply load it from cache instead of rebuilding it. But if a layer changes, Docker has to rebuild that again. And here is the most important part. When one layer changes, Docker not only rebuild the layer, but also rebuild all the layers after it. And this is exactly the problem happening with our npm install step. Before the npm install, we have the copy dot layer, which copied the entire project into our image. And because we still haven't added the Dockerfile itself into a Docker ignore, even changing the Dockerfile can trigger this rebuild process. But we can optimize this very easy by reorganizing our Dockerfile. The idea is simple. Instructions that change less frequently should be placed higher in Dockerfile so Docker can catch them more effectively. So it's better to put the copy dot after the npm install, but there is still a problem because for running the npm install, we need package JSON and package log JSON to running npm install. So we split the copy command into the other command. We have to write copy package and package JSON log before npm install instructions. So I write here copy, and this time I want to use pattern for copying the package JSON and package JSON log. I write copy, I package star dot JSON and dot for copying the package and package JSON log, package log JSON to app folder. Also, we need to change the ownership by --chan and specifying the app user and app group. App colon app Now, if I build a Docker image again, Docker needs to execute the npm install step once more, but from this point forward, as long as package.json or package lock.json do not change, Docker will load these upper layers from cache, and the build process will become much faster. Only when package.json or package.json lock changed, the Docker rebuilt the npm install layer again. Now let's move to the final step. And so far we have copied file, create custom user, create permission, and optimize the Docker file. But still there is one very important thing left: running the application itself. Our React application starts using npm start. And since it is the command, we should write it in a run command, but the main runtime command of the Docker should define using cmd instructions instead of run. So I write cmd, and inside the array format, I write npm comma start. And now let's rebuild the image again. I exit here, and as you see, image successfully built. This time when running the container, I no longer need shell mode. Instead, I use a port mapping. I map port 300 from host machine to port 300 inside the container, because our React application is running on the port 300. So 300:300, and now I should write the image name, which is React Test App v1. And now if I open the browser and go to application URL, you can see that our React project is successfully running directly from the Docker image. As you see, the front end still cannot access the data because backend server is not running yet. In the next part, we will create a Dockerfile of our Node.js backend project, and also you will learn how to run all services together using the Docker Compose. In this part of our series, we're going to move into the stage where everything becomes much more real world and project oriented. We're going to work on a real projects. In a previous video, I explained Dockerfiles completely and in detail, and together we created a Docker image for React application. And in the episode before, we'll use a Docker Compose to connect two different containers together, MongoDB and Mongo Express. Today, we're going to connect everything together using a Docker Compose file. Our project has a Node.js backend and a React.js frontend, and a MongoDB database for storing and reading the data. I already created a Docker file for both frontend and backend applications. And now we're going to use Docker Compose to build all the containers and establish communication between all the services. But before we do that, I want to fully explain the Docker files we created. First, let's take a look at our React Docker file that we built in a previous section. And after that, I'll explain the Docker file I created for Node.js project, which is located here, as you see. We'll go through everything step by step until you fully understand how Node.js Dockerfile is created. After that, I'll explain the YAML file that I previously created for connecting the MongoDB and Mongo Express. So let's start with React.js Dockerfile. First, I have created a Docker-ignore file. Inside this file, I specify the node module folder, because we specify file and folder. We don't want Docker to copy into the image during the build process. And since we don't, there is no reason to add the Dockerfile itself into the final image, I add the Dockerfile here as well. And now let's go to the Docker file itself and explain the code. First, we write our base image with from instructions. Our base image is official Node.js image based on Alpine Linux, which is very lightweight Linux distribution. And this helps us to keep our Dockerfile image size very smaller. Next, I'm creating a non-root user and group called app. Running container as a root user is not considered a good security practice, so it's better to create another user for container. And after that, I'm setting the app as a working directory inside the container. It means the next command will run inside this folder. And then I change the ownership of app directory to the app user and group. So this user has permission to read and write file inside the project directory. And once the permission is set, I switch the root user to app user using the user instruction, because the copy command always by default is done by root user. So I add a chown option to copy the package and package lock.json to our working directory, which is app. After adding the package into the directory, I can run npm install to download and copy all dependencies and create the node module folder. After creating the node module folder, I can copy all the files and folder, project files and folder into the container by running these commands. And with env instructions, we can specify the environment variable, which our environment variable is the URL of our API. So I set it here, and by expose command, we write the port number which our container is using. And finally, with the cmd instruction, I start the React application using npm start. Now let's take a look at our backend Dockerfile. The Dockerfile for Node.js application, which is located in backend folder. Just like before, I'm starting with base image, which is official Node.js Alpine image, because it is lightweight, and to keep the final image size smaller. Then I create the user app and group app, because running the container as a root user is not recommended, and using a separate user is a better practice. And here I set app folder as a working directory inside the container. From this point, all commands will run inside this directory. After that, I copy the package .json and package -lock.json to this app directory. It is useful because the Docker can cache this layer, which makes rebuilds much faster when dependencies have not changed. Next, I run npm install with run command, and running this command creates the node module folder and install all the dependencies. And after that, I install nodemon globally, because during the development, I want the backend server automatically restart. So I use a nodemon to run our API. After installing the dependency, I copy the rest of the project files into the container by this command. Then I change the ownership of the project files or any files and folders inside the app folder to app user and group. So this user has correct permission to access and modify file inside the application directory. After the permission is configured, I switch from the root user to non-root user, which is app user. And then here I set an environment variable for connecting the database. As you see, my database connection is MongoDB, and username and pass, and the address of the host, the MongoDB host, and the port. After the permission change and all of this, I switch from the root user to app user, and then I expose the port 3001 because the backend API is running on this port inside the container. And finally, I start the Node application using the nodemon on a server because nodemon automatically reload the development whenever changes are detected. In a production mode, you don't need to use nodemon. Instead, you can use npm index.js. Now let's take a look at our mongo.yaml file. This is the Docker Compose file we created to connect MongoDB and Mongo Express and make the container for them. Inside the services, I first create a service called MongoDB1. The name is and can be anything. The service uses the official MongoDB image, which is loaded directly from Docker Hub. Then I mapped a port 27017 of my local machine to the containers, and the MongoDB database needs two environment variable. I write here and choose the username and password for my database. And the second service is Mongo Express, which I choose a Mongo Express 1 name for this service. As you can see, it uses the Mongo Express image, and the port mapping is done here. I mapped the port 8081 to 8081 of the host. Then I add some environment variable for authentication. These credentials are used to protect Mongo Express dashboard with username and password. The first and second environment is related to Mongo Express dashboard username and password. And finally, these two username and password is the Mongo database username and password and should be the same as the MongoDB user pass. And finally, this line is very important. Here, instead of using the local host, we use the service name MongoDB1 because inside the Docker Compose container communicate with each other using the service name. So Mongo Express can directly find and connect MongoDB container through the Docker internal network. Our MongoDB container's name is MongoDB1. So for connecting Mongo Express to MongoDB1, I should write here MongoDB1. So far, we have created the Docker image for both backend and frontend. And we also write a configuration for MongoDB and Mongo Express containers. Now, to connect everything together, I'm going to create another Docker Compose file. So inside the root folder, here I create a new file. I docker-compose.yaml. This is the standard naming convention for Docker Compose file, and because of that, VS Code automatically recognizes it as a Docker Compose file and even change the icon and shows the Docker icon for it. Then I simply copy the mongo.yaml instructions into our new created Docker Compose file. Now for the next step, the first thing I'm going to do is to rename the containers to make everything cleaner and easier to understand. So instead of MongoDB1, I write DB for MongoDB container, and for Mongo Express container, instead of Mongo Express 1, I write and choose the name Mongo Express. Since the MongoDB service name changed, I also need to update Mongo Express configuration and replace a MongoDB server value with DB. That way, the two containers can still communicate correctly inside the Docker network. Now let's move on to the next step, where I want to define the front-end and back-end containers inside this Docker Compose file. So with the indentation, I write the name for my front-end container. I choose a name for that. I choose web as a container name, and for the backend container or service, I choose API. After defining the service name, the next step is to specify which image should use to create each containers, and then defining the port mapping and adding the rest of the required configuration. Now, since I already wrote a Dockerfile for my React app, which is here, the image for this container will be built from this Dockerfile, and because the image is not hosted on any Docker Hub or any other registry, I can't use image instructions here. So instead, I should use build instructions. So I write here with indentation, build. And as you see, it has two options. The first one is context. Context specify the location where Dockerfile exists, and the Dockerfile option let us define the Docker name manually. But since I use the default standard name for my Dockerfile, which is a Dockerfile with capital D, and there is no need to write or Dockerfile name here, so I can easily remove this line. I only need to provide the path where my Dockerfile exists, which is inside the front end folder. So I write here front end. Now let's configure the port mapping. For port mapping, I add the ports option, ports, and with indentation and dash, I map port 3000 of our host to port 3000 of our container. For now, this configuration are enough for the front-end container or front-end service. Now let's move on to the back-end container. I need to specify the Docker files, so I use build instruction. And for the API, the image is located inside the backend folder. So I write here backend. And for the Dockerfile name, I choose the standard name. So there is no need for this option. I remove it. And now I'm going to define the ports, and so I write ports, and I map port 3001 to port 3001 of the container. For the backend service, we need to add a few more configurations. The first important thing is defining the database connection string. If you remember, inside the backend Dockerfile, we store database connection string inside the environment variable called db_URL. We use this environment variable inside the application to get and set the database connections. The applications reads that value at runtime, but there is a very important difference now. Since our Node.js application is running inside Docker, localhost no longer points to our own computer. Inside Docker Compose, containers communicate with each other using their service name. So instead of localhost, we need to use the MongoDB service name, which is, in our case, is DB. So here I should change the localhost to DB. This way our backend container can correctly connect to MongoDB container through a Docker initial network. We should define this kind of configuration inside the Docker Compose file instead of hard coding inside the Dockerfile. The reason is that things like database URL, password, API keys, ports, and environment-specific settings are considered runtime configurations. These values can change depending on where the application runs. For example, in development, we may use one database. In production, we may use another database. And in testing, we may use something completely different. If we hard-code these values inside the Dockerfile, we would need to rebuild image every time something changed. But Docker Compose allows us to inject these settings at runtime without rebuilding the image, which makes the setup much more flexible and production-friendly. Now, so we have to take this environment variable and cut it from here and paste it inside the Docker Compose file. So I create another option here named environment, and I paste the add and name and value here. Now you may ask why we didn't move this environment variable, which is located in our front-end Docker file, into the Docker Compose file. The reason is that the React application runs inside the browser, not inside the Docker network itself. And because the network runs on user's machine, it still needs to access backend through the localhost. So for the front end, keeping the localhost for the URL to API URL is completely fine. And if we replace the localhost with API, the browser would fail because the browser has no idea what API means inside the Docker Compose networking. So this is an important concept to understand. Containers communicate each other using the service names like DB API, but browser communicate to the localhost and exposed ports. Besides these configurations, there are a few more important instructions that I want to add for the backend containers to work properly. One of them is restart always. This instruction is very useful because if our API crash or stop working for any reason, the Docker will automatically restart the container, and that way backend service stays available and come back online automatically without needing to restart it manually. Another very important instructions is depends on. Our backend containers need Mongo database to be running before it starts because backends need to connect MongoDB during the setup. Now, when Docker Compose start multiple containers together, sometimes database container may take a little longer to fully initialize. If API starts too early, it may fail because database is not ready yet. That's why we should write the depends on here, and we basically means that the current container is depending on another service and should wait for it before starting. For our API service, I'll add DB. The same thing applies to Mongo Express because the Mongo Express also need the Mongo DB to be running first. So I add depends on DB here too. And now there is one more important thing left inside the backend Dockerfile. As you remember, I use the nodemon index for starting the application. But in production, I may want to start the application differently. For example, I want to use the in node index.js command. Docker Compose allows to override a default command writing inside the Dockerfile by any other command. If I add the command instruction here, I can write any command. Docker will automatically execute this command instead of a default cmd command located in Dockerfile. So I write here node index.js, and Docker Compose will run this command instead of the nodemon index command. Our Docker Compose file is finally ready. The setup will create 4 container, web API, DB, and Mongo Express. Now let's move to the terminal and run the Docker Compose. So Docker Compose can build the front end and back end image and then create and start all 4 containers together. We have to navigate to the folder which Docker Compose located, and here we should write the docker-compose up command. And since we use the standard file name for Docker Compose file, which is docker-compose.yaml, we don't need to specify file name here, but if you use another file name, you should write the file name after -f option. And there is more important things here. I'm also going to add --. build flag here, and the reason is Docker Compose app by itself may reuse existing image if we already built before. So if we recently changed something inside the Docker file or modified our application code, Docker might still use the old cache image. By adding -- build, we force Docker Compose to rebuild the image before starting the containers. This ensures that all latest changes are included. You can also add -d flag at the end of the command. -d stands for detached mode. Without this flag, Docker Compose run in the foreground, which means terminal stay attached to the containers and continuously show the logs in real time. But when we add -d, Docker runs all containers in the background and immediately give us back the control of the terminal. So I run this command without -d. I stop this container with Control C and I want to run it in detached mode. So I run it in detached mode. As you can see, Docker successfully built both front-end and back-end images, and all containers are now started. And if you look carefully, all the images and containers has a prefix, which is in my case Docker test app. Prefix actually is the name of the project folder. As you can see, the project folder is Docker test app, and the Docker Compose file is located in that folder. Docker Compose automatically use the folder name as a prefix for the image and container, and even the network it creates. Now, before testing the application, let me show you another very useful command. You remember we use Docker PS to see the currently running container in our machine, but if we specifically want to see the container created by our Docker Compose setup, we can use Docker-compose PS. This command gives us a cleaner view of all services defined inside our compose file. Now let's test the application. First, I open a browser and test the database UI, which is Mongo Express. The address is localhost 8081, and I write the username and password. As you can see, our database is ready. I create a user DB database here. And inside the user DB database for my application, I need a user table. So I create it here. Now let's test our application, which is located in localhost 8200. I can simply add a user, and if I refresh in the Mongo Express UI, you can see the user is created, so my application is working correctly. Now let's stop the Docker Compose. You can stop the Docker Compose by running the Docker Compose down. This command stop all the containers and also remove the network created for this container. So if I run again the application, and as you can see, after removing the container, the application is no longer available. Now let's bring Docker Compose setup one last time. And as you can see, all the services are built and started. But if you go back to the database and refresh the database, you'll notice something very important. As you can see, the database, the table, and all the data are gone. That's because when container gets removed, the data stored inside the container is removed as well. So if you need more important or persistent database data, you should use Docker volumes. And in the next part of this series, I'll explain the Docker volumes completely and show you how to persist your database data perfectly. In this part of our Docker course, we're going to talk about Docker volumes. A volume is a storage that exists outside of the Docker. It can be stored on host machine or even on the cloud. So why it is so important? Because containers are naturally temporary. Files inside the container are stored in a temporary writable layers, and when a container gets removed, the layer is removed too, and which means all files data stored inside the container are lost. This becomes a serious problem in real-world projects. Imagine your database is running inside a container, or users upload files. Their files are located inside the container, and logs are being stored also inside the container. So if the container is deleted, all of this data disappears and we do not have access to them anymore. Fortunately, Docker provides a solution for this problem, and it is storing data outside the container. That is exactly what Docker volumes do. Volumes allow us to persist data even after containers are removed, and also easily create backups and also share data between multiple containers. Now let me show you the problem practically. In the previous sections, we created a Docker Compose file with 4 containers, a web container, which is a React.js frontend, and an API container, which is the Node.js backend, and a MongoDB container and Mongo Express. Now let's start the project by using docker compose up build -d. As you see, all the containers are image are built and created. Now, if I go to the Mongo Express UI, as you can see, I create a new database named user_db, and inside this database, I create a new collection which is called users. Now, inside my simple application, I'm adding a user named Sarvin. Now, let's check it. Everything done correctly. As you see, the user Sarvin is inside my collection. Now, if we came back to our terminal and stop this container by running docker -compose down, as you see, all the containers are removed. And if I start these containers again, if I go back to Mongo Express, as you can see, my database is deleted. Even my collection and the data inside the collection are deleted because we don't use volumes, and all the data are stored inside the container. And because we delete the container, we remove the container files and itself are removed, so we lost our data. For solving the problem, let's use Docker volumes. But before that, let's open a terminal again, and inside the terminal, let's run Docker volume. Here you see the list of available commands. For example, here we have create, which create a volume. We have inspect to view the detail of a volume, and also ls to see list of the volume, rm and prone to remove volumes. Let's start by creating a new volume. I create a volume by docker volume create command, and here I specify a name which is Sarvin _ data. Now let's see the list of the volumes with docker volume ls command, and as you can see, we have some unknown volumes here. And here is the volume I created. Let's inspect this volume by docker volume inspect Sarvin -data. This command gives us a detailed information about the volume. First, we can see the creation date, as you can see. Then we have the driver. By default, driver is local. The driver determines what type of storage manage the data. In our case, it's local because it's located in our host. The drivers also support network storage, remote storage, and also cloud storage. In our case, we use the default local storage. Now let's move to the next important field, which is mount point. This is very important. The mount point shows the actual location on a host machine where the volume driver is stored. Notice that the location is outside the container, and the data physically exists in a host system, non-Linux. You can use this to find the volume, but on a Windows or Mac, we won't see the normal physical path like this, because on Windows and Mac, Docker runs inside the Linux virtual machine, and the volume are stored inside that Linux environment, so we cannot access physically to this path. Right now, this volume is empty because no container is connected to it yet. Now let's connect this volume to a container. So I right clear, and I want to connect Mongo container to this volume. So I use Docker run -it because I want to run it in interactive mode, and for defining and volumes we use -v, and then we specify the name of the volume, which in my case was serving-data, and then colon. And then we specify a path of the container, which we want these data become persistent. So I write the path app-data. If there is no folder named data or app, Docker automatically creates it. And now I specify the image name, which is Mongo, and I want to run in shell. So the container is started, and I created, and I access the shell. So I go to data app folder, and then to data folder, and here I want to create a file. Let's first use the ls to see what is inside the data folder. It is empty, so I create simple file and write serving style coding inside it by this command. The file name is serving.txt. Now if I press ls, you can see that the file is existed inside the app.data. Now I press I write exit to exit the container. Now I want to remove this container to see if the data is gone or not. So I write docker ps-a, and that is my newly created container. So I delete it with docker rm and -f to force it to remove. Now let's create a container again with the same volume. And let's move to app and data folder, and let's type ls. And as you see, the serving.txt exists even I remove the container, which is very awesome. Another powerful feature is that we can store one volume between multiple containers. Now let's exit here, and I want to create another container with another image, and I wanted to use this volume for this image too. So I run interactive mode, and I use the same volumes, which is serving data. At this time, I want to change the path, so I write serving app serving, and also I want to change the image name. I want to run Mongo Express in shell mode. I forget to add -it here, and here, if I go to this folder, which is serving, I can access the serving.txt file, as you can see here. If we need multiple volumes for a single container, that is also easy. We simply define multiple v options like docker run -v volume 1, and for example app, and the second container, another -v, another volume name, and another path, for example app2. Each volume gets mounted into their own directory inside the container. So far, we've been using the Docker run command to create containers and attach volumes. But in real-world projects, we usually work with Docker Compose. So now let's move on to the Docker Compose and learn how to define and attach volume. First of all, we need to decide which volumes our project needs. So inside the Docker Compose file, in the same level of the service, right here, volumes. And here we list all the volumes we need to create. I want to create a volume named MongoDB-Servin, and we have to add the colon. You can specify here a driver name. For example, you can write driver local, and because the default driver is local, there is no need to specify it manually. But if you use another driver, or you want to use the custom driver, you can write it here. After writing the volume names, it's time to add the volume for each of the service which needs the persistent data. I want to add the volume for MongoDB containers. So here I write volumes. As you can see, it is written at the list, which means we can attach multiple volumes to a single container. The syntax is simple. First, we write the volume name. In my case, is MongoDB Servin. I copy and I paste it here, and then colon. For MongoDB, we want the database file to survive even after the container is removed. So when we check the Mongo image inside the Docker Hub, as you can see here, the path for storing the database data is /data/db. So I write the path just here, that data-db. This is where the MongoDB stored data inside it. Now let's test it. Let's go back to the terminal, and with Docker Compose up, I create all my containers. As you see, let's create a database named ServinDB, and let's create a collection named users. And now let's add another new user, which name is Servin. Let's check it again inside the database. As you can see, it's created. Now let's stop the containers by running the Docker Compose down. As you can see, all of my containers are removed. Now let's start it again with the same command, Docker Compose up. Let's go back again to Mongo Express. And as you can see, my data is still here, and which means our MongoDB data is now persistent, and thanks to Docker volumes. In this part of our Docker course, it's time to deploy our entire application to a server. For demonstrations, I've rent a VPS, and together we're going to deploy our complete application step by step. The application includes the React.js frontend, a Node.js backend, and a Mongo database, also a Mongo Express and dashboard. We will use Docker and Docker Compose to get everything running on our new server. To connect the VPS, we'll use the PowerShell just like we normally do. So here in PowerShell, for the first time, we will connect using the root user account. So I write here SSH root @ the IP address of the VPS, and then press enter. At this point, we need to enter the root password. Keep in mind that when you're typing a password in Linux terminal, nothing will appear on the screen. This is completely normal. Just type the password and then press enter. Once you log in, the first thing you are going to do is to create a new user account. Now you might be wondering why we don't simply continue working as root user, because the root user has restricted access to entire server, and while that might sound convenient, it is actually risky. A simple mistake such as running a wrong command, deleting a wrong directory, or executing an unsafe script can affect the whole system. So for security reasons, it's considered the best practice to perform day-to-day administration tasks using the regular user account and only use relevant privilege when necessary through the sudo command. This approach reduces the risk of accidental damage and improves the security. So before installing anything else, let's create a dedicated user and use that account for the rest of the setup. So here I clear the screen, and the first thing I'm going to do is creating a new user. By running the command add user, I want to create a new user named Sarvin. We have to specify the new password for our new user, so I write the password here. Retype the new password again and type the full name if you want. Also room number, work phone, home phone, and other information, and then press yes to creating the user. Once the user has been created, we need to grant administrator privilege by running user mode -a capital G sudo and the name of our user, which is Sarvin. User mode is used to modify an existing user account. -a means append, so we are adding the user to additional group without removing any existing group memberships, and -j sudo specify that we want to add the user to sudo group. Users in sudo group are allowed to execute administrative commands using the sudo command. So this gives us a flexibility to perform system-level tasks when necessary without logging as a root user. After creating the user and guaranteeing the sudo privilege, we need to switch to new account in one of these ways. The first way is typing a su dash username, which is Sarvin, and another way is simply exiting the account and logging it again by changing the user, which I write here. I change to user root to user Sarvin. Again, you need to specify the password here, and as you can see here, the user is Sarvin now. Let's clear the screen again. At this point, we're ready to install the Docker on the VPS. To install Docker, I recommend the following official documentation. So open your browser and type here install Docker engine on Ubuntu. And here the first link is related to Docker docs. Inside this page, you can find the documentation on how you can install the Docker on your Linux here. The first thing we need to do is to update our apt package. So I copy this command and here I execute this apt update. We need to write the password again for user Sarvin. Now let's move on to the second command, which is install CA certification. Here I paste it again. Then the next one. And this command. Here we're downloading the Docker official GBG K. And let's move to the next one. And here, let's copy all the commands from here and paste it here. This commands adds Docker official repository to Ubuntu package sources. And finally, let's run the sudo apt update to refresh the Ubuntu package index. This allows the system to fetch the latest package information, including Docker package that are now available on repository we just added. And let's go to install Docker packages here. Oh, here. And yes. This command installs Docker engine and all essential tools that comes with it, including Docker Compose. And let's move to the next command. Now our installation is complete, and it's a good idea to verify that everything is installed correctly. So let's check the Docker version by docker-v command. And the next step is here, as you can see, is to check the Docker status by sudo systemctl status docker. Let's check it and copy and paste it here. As you can see, Docker is running and everything is okay. To exit here, just press Q. And if for some reasons your Docker is not running, you should run it by executing this command, sudo systemctl start docker. If you restart the server, check the Docker status. If it is not running, you should write a sudo systemctl start docker. And finally, let's verify the installation by running this command, sudo docker run hello world. And this command downloads a small test image from Docker Hub and runs it inside the container. So if you see the hello from Docker message here, that means Docker is installed correctly and the Docker is running and your server is able to pull and execute a container successfully. At this point, we can be confident that our Docker installation is working properly and we're ready to deploy our application. Let's try running a simple Docker command, which is Docker PS. As you can see, we got a permission error because our current user doesn't have permission to communicate with Docker daemon. We can run this command with sudo Docker PS. But if you don't want to use sudo every time you want to execute a Docker command, you can simply add the user serving to Docker group by writing the sudo user mode -a Docker serving. But after running this command, make sure that you have to log in and log out again. And once you log in again, you can write the Docker commands without sudo. So this time I can simply write Docker PS. And as you can see, I have a privilege to run this command. With Docker ready to go, it's time to deploy your application and transfer project file to the server. The easiest and most common way is using Git. You can use your own Git server or a Git repository. In my case, I already pushed my project to my serving style Git repository under the Docker test app. Before cloning the project into the server, there's a few changes you'd need to make when moving your application from localhost to VPS. First of all, if your frontend was previously sending requests to localhost, here in Dockerfile, as you can see, the IP address is HTTP localhost port 301. And when you transfer your website, your API to the VPS or other server, you need to change the API address to the IP address of the VPS or the domain name of the VPS. In my case, I have to change the localhost to the IP address of the VPS. I transfer this environment variable to Docker Compose file here. As you can see under the web service, I add a new environment. I write an environment variable, VPS React App API URL, and change the local host to the IP address of my VPS. So the API request will send to the VPS address instead of the localhost. You also need to update your backend course configurations to allow the request coming from your server's address. Here in the index.js file, in the app.use core policies, I add another item to the origin, and there was localhost 300. I add the HTTP, the address of the VPS, to the course policies. Otherwise, the browser will block communication between the front end and back end. So you have to change this. Also, in the Docker Compose file, as you remember, maybe in the database, I mentioned a name, username, and password here, and also I write the username and password for the dashboard of the MongoDB. Here, serving pass. For security reason, you may want to change this username and password. So here, if you need and if you want, you can change it here. Once our adjustments are made, it's time to install the Git and clone our repository. So let's move back to the PowerShell here, and for installing the Git, simply we write sudo apt install Git. Once the Git is installed, we need to choose where we want our application files to copy or leave on our servers. In my case, I'd like to keep all of my project inside the directory called apps. So let's create this directory here. We create a directory with mkdir command and the directory name, which I want to be apps. Let's move inside this directory. So I write cd apps. So it's time to copy our application files from GitHub. So let's head over to our Git repository, and inside the code here, copy the clone address, HTTP address of the repository, and here inside the PowerShell, I write the command git clone and then the HTTP URL of our Git repository. As you can see, after cloning process is completed, let's run again ls, and as you see, here is our repository name. Let's go inside the Docker test app and another ls to see what is it inside the directory. As you can see, all of my files are copied, including the backend folder, frontend folder, and the YAML files. At this point, we're ready to deploy the entire application using Docker Compose. Since our Compose file already defines all service network volume we can bring everything up with a single command, which is docker compose up -- build and -d to run everything in detachment. As you can see, Docker built the image and also created the network volume, and all the containers are started. Now let's verify that everything is working correctly or not. So I open a browser on my local machine and I navigate to the VPS address, followed by port 8081 because I want to open the Mongo Express dashboard. As you can see, the dashboard is open. It shows that the database is created successfully, and now I create a new database named UserDB, and also I will create a new collection inside the database UserDB. Now let's test the front end. I navigate to port 8080 of my VPS As you can see, the React application loads successfully. To make sure everything is working properly, let's add a new user. I create a new user named Sarvin. And as you can see, it's created. Let's check the database by refreshing the collection page. As you can see here, my user is created. As you can see, everything is working exactly as expected. The front end can communicate with backend, the backend can communicate with MongoDB, and all of our containers are running properly. With that, we'll successfully deploy our entire full stack application to a VPS using Docker Compose and a single deployment command. And with that, we reached the end of our Docker course. First of all, thank you for sticking with me all the way through. I know it was a very long course. If you have completed it, you have built solid fundamentals on one of the most important skills on modern software development. Now you know how to build, run, connect, and deploy containerized application using the Docker, and more importantly, you know how all these pieces fit together in real projects. But we are not stopping here. In the next videos, we will dive into the topics like Nginx, custom domains, SSL certificates, private GitHub repositories, and production-ready development workflow to take your skills even further. If that sounds interesting, don't forget to subscribe and turn on the notifications so you don't miss the next videos. And thanks again for watching me. And as always, happy coding!